Hello and welcome everyone to the Smart Contract Hacking course. This is the first episode. Today we will learn about the access control vulnerability in a smart contract and in AVM network. So let's deep dive in OWASP's smart contract top 10. So you can see that a smart access control vulnerabilities is on number one. So let's understand what's this vulnerability is and why this arises, and how can we hack it as a smart contract hacker, and how can we mitigate it, or how can we prevent this from happening. So we will be using hard hat to initialize this project and run this project locally. So you can configure hard hat project, and in contract there is already uh, some files given, like initialized by hardhat itself for testing purposes. So we can delete this. So let's create a contract. Let's say we name it access control or something. Let's say zero dimension dot sol. So what we are going to do, so basically we are going to make an ERC20 token, and which will have mint function, where only owner have the authority to mint function to other users, and he can mint the tokens to other users. So you as an hacker, uh, you need to hack this contract, and without even on you being without even honor, you need to transfer this all the tokens to your account. So let's first create the contract. So sptx license identifier mit pragma. We need to specify the solidity version. Solidity, let's say 2 or 28. So we will be using OpenZeppelin for creating the ERC20 token. So let's go to OpenZeppelin. ERC20. So we can import it, copy this, paste it here. So it's saying the ERC20 token is not installed, so we need to install it first. So you can install it by npm install copy this, paste it. So it's this install the package. So let's get back. So let's create the contract. Let's say name it zero dimension token, and we need to create ERC20 token. So make sure to call it. So basically is inheriting the token from ERC20.sol, which is implemented by OpenZeppelin. So we are just inheriting that token from ERC20, basically OpenZeppelin. So you can visit this ERC20.sol file in GitHub. So they have implemented it. So this is basically a standard which is identified by all EVM developers, Ethereum developers. So we will define a owner. So address public owner, and then a constructor, and that will take initial supply. So initial supply is like how many tokens as a owner you want to distribute in the chain. So we are creating ERC20. So name of the token, let's say 0 token, 0 dimension token, and it expect a symbol, so let's say JDT for now, and that's it. So we will initialize the owner to message.sender. So message.sender is basically the deployer of the contract. So this is important, like the constructor in EVM is called once only when the contract is deployed. So once the contract is deployed, so this constructor will be called only once. So owner is the message.sender is basically the deployer of the contract. So owner is fixed here, and we will use the mint function. This mint function is implemented by OpenZeppelin in ERC20.sol. So you can check this out. So mint message.sender, we will be minting initial supply. So initial supply is the total supply which is uh, like supplied during deployment of the contract. So after that we will implement a function mint, which will take address and amount as a parameter, and this will be a public function. So this function will basically mint the tokens to users, and we will be creating a modifier. So message.sender, so it's checking message.sender is owner, and later we are continuing the execution of the code. So this is the all, that's all. This contract have this functionality. So basically this is ERC20 token, which has only mint function. So make sure that only owner can mint this token. So owner is defined upon the deployment of the contract. So you as a smart contract hacker, you need to hack this contract and mint the token to your account. Basically mint all the token to your account, to your address. So pause the video and try to figure out what's the issue here, and can we hack this contract, and how can we hack this contract if yes. So I hope you guessed it right. So basically issue here is only owner modifier. So basically the contract is implementing modifier only owner, so which makes sure that only admin should call this mint function as expected by the developer. But there is a bug in only owner modifier. So this modifier is checking whether the sender is owner or not, but it's not reverting the transaction. So here if anybody, let's say attacker, calls this mint function directly, so he will be able to mint the all the tokens to his account. Basically this only owner is not reverting the function. So this will only check whether the message.sender is owner or not. So even if he is not owner, still he can execute this function, because there is no revert function here. So let's try to hack this. So we will create a new file, let's say test1.ts. so we are using TypeScript. So new hard config is basically using TypeScript. So let's implement we will be using chai for testing. So let's import expect from chai, import network from hard hat, not ethers, hard hat, not capital N, a small n, and we will we will import ethers from network.connect. So this is all the setups. So now let's describe the test. So this is simulating the attack, and it expects a function. Let's describe the owner, basic any, and attacker, which is any for now, and we need to deploy the contract as well. So function. So let's get owner and attacker from ethers.signer, await ethers.get signers, right? And let's get the contract from contract factory, await ethers.get contract factory, and we will copy the contract name. So this is the contract name, 0 dimension token. So we will make sure to copy this and paste it here. And who should deploy this? So owner should deploy this. So we will mention owner here, and let's say this dot token contract factory dot deploy ethers dot parse units. So let's say we are initializing this much of token initially. So 18 is basically making sure that 18 zeros after the this number. So basically it will make sure this number of ethers. So let's deploy this. So this is the initial supply, guys. So this is the initial supplies we are passing it upon the deployment. So contract constructor expect initial supplies, initial supply parameter. So we are make sure to pass this parameter. So upon deployment, this contract will have this much of tokens, and owner will have access to this token. Owner can mint this token to other users, and yeah, that's it for. So you as attacker, you need to hack this contract and mint all this amount to your address. So let's say mint this token. So we will connect owner dot mint, and let's say mint to owner address, pass units. Let's say mint 100 tokens for now. So this is basically minting 100 tokens to owner address. So owner is calling this contract. So basically he is the he can mint the token. So here this is expected behavior, there is no problem here. So let's say so this is the final this is the part where attacker is attacking. So attacking the vault, attacking the contract, let's say sync function, this dot token dot balance, let's say initialize a variable token balance to ethers dot provider dot get balance, and we will pass the token address, basically contract address target. This dot token dot connect. We are calling the min function by attacker address now. So attacker is calling the min function, and make sure to pass the attacker address here, and he is passing all the token balance. Let's check the attacker balance now. This dot token dot balance of attacker dot address. So this is the attacker balance after the attack. So we will write our test now. So this dot attacker balance, this should be equal to this dot token balance. So first we are getting the token balance, which is the balance of the token contract which was deployed earlier, and we are at this line attacker is calling the contract and minting the all the tokens to his address, and after that he is getting the address of getting the balance of his own balance from his own address, basically the how much token did the attacker have, and we are checking the attacker balance should be equal to the token balance. So all we are making sure that all the token should have been transferred to the attacker address. So after the attack function, we will expect that the token balance should be 0, because after the attack the token balance would be 0, the contract balance would be 0 to be equal 0. That's it guys, we have successfully hacked the contract. Let's see if we are able to run this test, pass this test or not. So we will execute this test by npx test command, which is in test folder, file test1 dot ts. Let's run this. Proceed. npx hard hat test, forget hard hat. So run the test by this command. So our test passed successfully. So after the attack, the token balance, the deployed contract balance is 0, and attacker balance is equal to the total balance. So congratulations, you have successfully exploited the vulnerable access control vulnerability. That's it. Thank you. See you in next video. Make sure to subscribe and like the video.